Hey folks, so today we will talk about the concept graphs. And concept graphs have a lot of interesting solutions and entities, but just to recap you, that concept graph is p-party graph where you have two kinds of nodes. Yeah, so you have the entities and you have the relations. So relations are also the nodes. And in this case, you don't have actually the labels on relations because you just move this information to the node, right? So you have really simple arrows that just point from one entity to the relation to another entity. And that's it. But the idea of the concept graphs actually have big two parts. So first of all, you have the graph. Yeah, so it's clear, it's b-party graph, and we have the simple rules that we point to the from the entity to relation to the another entity. We never point to from relation to relation, or we're not pointing to entity to entity. That's as it's clear. It's fair enough. Another big part, it's actually the not the ontology, but some kind of hierarchical or vocabularies that define the relation between the entities or define the relation between the relations. So relations would form the hierarchies, have the subclasses and all other things. And it's quite important to understand that we have this two parts, simplified hierarchical ontologies actually of vocabularies, and then the full-scale graph. And yeah, so that's the concept graph as is. And concept graph could be quite good for artificial intelligence memory because it's captured already quite interesting things. It's captured relations, it's captured the entities, and one also important and overlooked thing of the concept graph, it's this instances and general entities. So when we say that Volodya, it's an instance of person, but sometimes we have the statement in the memory that, for example, the friend of Volodya did something, and it's a fact, and we clearly understand that, for example, it's a person, but we don't know which of the person. Then we could create some kind of instance that, let's say, doesn't have name or something special. Yeah, it's one case. Or another case that we say that all persons are mortal, and then we have the generic case, and we could say that it's a person and then create some kind of relations. And it's quite broad bucket. So if you don't have the contract instance, should be it's completely generic, or should we have some, for example, representation of the patterns that have this more contextual meaning? And it's where the concept graphs introduce the wildcards and generic entities that you could refer to the type instead of referring to the concrete instance. And it's yet another quite big overlook part of the concept graph. Another quite big overlook, the power of the concept graph is relationless nodes, and I have the article about it and why it's matter, and that you could have the multi-party and multi-entity relations that was not feasible and not possible to model in classical RDF, for example. Yeah, but yet another trick that you could have the hierarchies of the relations that could form some kind of substitution and all other thing. It's also quite interesting modeling thing. So, and the next step that I came to describe that we could combine the concept of the concept graph, I know is tautology, with the concept of the event graphs. So we bring the entities and relations together with the temporal component and events in the same graph. But right now, the events is tricky because event could be the entity that have the temporal relation with another events. But event could be even treated as a relation that this event group together all these entities somehow. And for sure, the event could be the subgraph itself that have the complex entity relations. So it's a quite interesting domain to discover. But this concept graphs and event graphs could be the good combination for modeling the artificial intelligence memory. Yeah, so let's think about it together and model something together. If you're working in the same space, I will be happy to have a chat with you and talk about it. See you next time. Choose.